So I have heard a lot of interesting talks about the data science, about big data, about neural networks, how to process all of that, and how to get unique insights on the data. I'm talking a little bit about the next step. What do you do with the data? Once you have the analyzed data set, how do you actually take it to the public? How do you create apps on top of it? And how do you create visualizations on top of that? And so I'll be pointing out especially challenges on combining different kind of data sources and different kind of data formats. So a bit more on the engineering for the web and the mobile apps side of the data science part. So quickly, who am I? I'm Juha. I'm doing nowadays mostly software architecture, planning those systems, and by heart, I'm still a software engineer. If I write code, I usually write Python. So it's the right conference for me. I work for a company called Wiredcraft. We are a digital product agency, about 30 people in Berlin, in NYC, and in Shanghai. We work a lot on data-centric projects, not as much in the data science part, but more on the creating products on top of data, or sometimes about data management and presenting the data. So we have been helping many build many research groups. When they have the research data, they want to build something on top of it, and we help them to create the strategy and build the system and also design the user experience. And one of the projects was for the World Bank, where we worked on the open data portal. So just quickly what we do, strategy and product design, DevOps, UI, UX, data visualization, web and mobile development, and APIs and microservices. And actually creating an open data portal kind of nicely combines those all into one package. So that's why I prefer that kind of projects. It kind of combines all the interesting stuff to me. I am currently based in Shanghai. It's very different from Europe, but the software engineering feels the same. They don't write in Chinese, actually, the code, so I can understand something. And I've been there for 3 years now. So one of the projects we have recently been working on is the revamped World Bank Open Data Portal. Their old site was a little bit outdated and it was not very mobile friendly. And based on our visualization experience, we created a new experience totally from scratch. And we tried to fit it both for mobile and tablet as well as laptop interfaces. So here's a quick screenshot on just to give you an idea of what I'm talking about. Creating a user interface that can combine different data sets, and you can select what pieces of data you want to visualize, and everything is interactive. You can hover over those lines and you can select filter data directly on the front end, and you can also get to the source data. So it's very important that while you are showing the data, you are actually also communicating what are the sources for data and how you can download the source material. Some of the similar projects we also have done data management systems. For example, we worked on the Myanmar elections, creating part of the information management systems for them. So we have quite big projects. Just to get some of the terminology right, here's one screenshot of one of the projects where that was very geospatial, where we created a choropleth map of the data. Some of the important things is that we made it interactive so that when you can hover out on different sites, you will see an effect on which part is hovered on, and you can see tooltips to give you more information, and you can also click each of those shapes and other parts of the user interface reflects what you have selected. So that's some of the magic of JavaScript. What I will talk about is how to create the systems to visualize research data, especially for the web. How to take the data and what are the steps you need in order to create the beautiful user experiences you need. And I make some especially remarks for the geospatial data. There's some tricky parts related to that one. And how do you actually fetch and combine data from different sources, and sometimes it's in different formats, and how do you manage that all? And I'll try to highlight some of the potential problems you might face if you are thinking about building visualizations. Can I just maybe at this point ask how many of you have built some visualizations for the web you have actually published to everybody? So there's not that many, but it's probably a good audience for me then. Maybe I can give you some confidence so that everybody can start building those. So specific things to research data. So the case I'm talking about is research data where there's already a limited set. It comes usually from not that technical people. They maybe did a study or somewhere, or did a user study, and the source material might be in spreadsheets or CSVs or something, and probably it has never been read with computer. So there's some challenges related to that. Usually the heavy data processing is already done for you. I'm not gonna touch on the machine learning or any other that cool stuff. And it can sometimes even be in Excel spreadsheets, and it's by no means big data, so there's no challenges related to that one. Just the general system architecture, give you an idea. The thing that comes closest to the data science is the data processor, the one that has to actually fetch the data and process it and feed it to the database. So if you want to put complexity somewhere in the system, put it there. Database, usually we try to keep it as simple as possible. We pre-calculate a lot of the things on the data processor side so that the database can be kept quite simple. And it doesn't matter if there's some duplicate data because it's one-way data flow, so it's easy to manage the synchronization. The data interface is basically the HTTP API in most cases. Again, point of that is just to give you access to the database, so keep it as simple as possible and leave some work for the presentation layer. For the web presentation layer means the web application, and nowadays JavaScript is so powerful that you can do so many things on the front end directly, including filtering and all the kind of interactions and all kinds of styling. So there's a lot of possibilities to do on the presentation layer directly. And that's what the end users care, right? They only see the user interface. So while you are producing the data, remember that user doesn't really care if you have cool API. It cares if you have a cool user interface. Some things about the data fetching, the first part. First of all, encoding. It's rare that you get everything in nicely formatted UTF-8 format, and sometimes even if you think that your source data shouldn't have any encoding problem, maybe it's all ASCII you think, but there's always some weird characters or copy-paste error or invisible characters that are not UTF-8 or I mean not ASCII or something. So make sure that you have a good validation step and you take care of the source material encoding from the start. Usually the person who generated it, he knows what is the encoding, so usually you have some way to know what should be the encoding. Expect the connection errors from remote connections. If you are lucky, you have some API endpoints that you can pull the data directly from, but rarely it works every time fluently. So expect the connection errors and be prepared to retry. Sanitization, there's always some kind of, if the source material has not been programmatically compiled before, there's probably some kind of copy-paste problems. It's normal to have like line breaks in middle of the words or something weird like that. You can see everything once you see enough of these research data sets. To the type checking as early as possible. You can see detect a lot of different kind of typos and also unexpected things if you do the type checking and typecasting early enough, especially stuff like dates. It's easy to have one date that says unknown or just unexpected things. Just do the type checking as early as possible. And all of this is useless if you don't have a good logging or if you don't have a good way to present the problems. I think earlier today, somebody said that it's good to break if there's any kind of error. And I think, especially at the start of the project, if you detect any kind of warning, just break it. It will force you to fix the problem. And if you just print a warning log somewhere, nobody will fix it. Example of the typical thing that can happen is that you have CSV file and at first it looks like it's all okay, and then there's a word called unknown there. And this happens sometimes when the research truly has unknown value and they don't know how to represent it sometimes, so they just write it unknown. As an engineer, it's hard to predict when this happens, so you need a good validation. Mapping. By mapping, I mean usually, for example, geospatial data, you have some data that maybe refers to countries, and then you have shapes that have some IDs. Then you have to somehow combine those two. For geospatial data, there's ISO 3166 standard that actually standardizes the country codes with either three-letter alphabet or 2 letters. But it's not as simple as that. There's a lot of disputed areas around the world. So if you have want to have a nice, smooth visualization that doesn't have any holes in there, you have to be pretty careful on the standards that you are using. For example, some of the disputed areas around the Middle East. And pay attention to coordinate systems. It's actually not that easy to figure out what is the coordinate systems of the shapefile you are using. And one good way to detect that is to install a QGIS application on your desktop and just load it in there and see if it matches your base map. And you don't necessarily have to use the same mappings as the source data uses. For example, if your source data uses the 2-letter ISO codes for the countries, but you maybe want to, in the web user interface, in the URL, you actually want to say, use the country names, or maybe the 3-letter to make it more user-friendly. So you might actually consider choosing how you use the mappings early on in the process. I'll try to not have any code. This is the only code I think I have. It's just quick introduction on don't be afraid of the shapefiles. It's not very good standard, and the library is not very good actually. But but this is all you need to read a shapefile and transform it into a GeoJSON file. And just to go through quickly, GeoJSON is the format that is standard for web to represent shapes. And it's actually pure JSON, so you can actually create a Python dictionary and just dump it as a JSON in the end. So at the top, you generate the top-level JSON structure. Then you get the field names from the shape files. And then you just loop through all the records that are the different shapes, for example, different countries on the shapefile. And then you read the values from that record. You zip it up with the field names and make it as a dictionary. Then if you have any other data sources, you can just add them to the Python dictionary. And then you create the GeoJSON feature dictionary that then you, in the end, append to the features list of the GeoJSON structure. And then you can just dump it as any other JSON file and it will work. You can load it very easily to Mapbox or any other application that supports GeoJSON files. So it's very simple. A few things about data transformation. After you have loaded up, you have to usually transform and think, how do you want to represent it in your system? Use JSON everywhere unless you have good reason not to. I think in this conference I heard good things about message pack, and I agree it can be much more efficient. But JSON is much more standard for the web tools. So unless you have a good reason, stick to JSON everywhere. Usually you should use GeoJSON or TopoJSON for geospatial data. The difference there is that TopoJSON is much more compact. And it does cool stuff like if you have two features that are next to each other and they kind of share the border, GeoJSON have to kind of draw the border twice, but for TurboJSON, it can understand that they are the same, and then it just draws one line. So it can help when you simplify the features. You don't have those 1 pixel breaks between the features if you use TurboJSON. It might sound a bit funny that you might actually generate the whole data set as an option. Like for some cases, because the source data set is so small, there's just limited amount of different combinations of visualizations or possible user interface options that you can actually pre-generate the whole data set as static files. So you don't necessarily even need an API to do any data crunching. You just generate, for example, GeoJSON files that already has the data that the frontend needs. So you can skip the API layer in some cases. And it's a bit more time consuming on the backend, but it simplifies so much on the API side. And usually it's a good idea to combine the data directly to the GeoJSON features. As I told previous slide, it's very easy to just inject the data directly to the GeoJSON. So it makes it a lot easier on the front end to present the data on the map. And try to keep the data structure on the database as flexible, as extensible as possible. Just try to keep thinking, what is the next step? After 2 months, when this is ready, what will I add to it? And usually it's something like recommendations or business intelligence or another data set that might be a little bit different. So try to keep everything data-driven, make stuff configurable on the database level. And the last thing that you have to do for the web is you have to simplify the shapes. Usually the shapes that you download as a shapefiles are pretty big, like 50 megabytes is normal. So you have to simplify it to be easily usable. Mapshaper.org is something really cool that I use to just try out how small I can make it. They have a website that you can just upload a JSON and a GeoJSON, and then you just click simplify, and then they have a drag drop slider that you can make it as simple or complex as you want, and then you can download it and see how big the size is. It's actually written in Node.js, so they don't have a Python module, but I think Python has some libraries that use the same algorithms. So if you go to their open source page, if I can find out what algorithms they use to simplify the shapes. And you can actually see that red dots where it's starting to break. It's starting to overlap some of the things because I have simplified it too much. So it's really nice tool to just see what is possible by simplifying. The data interface, also called the API. Keep it simple. It really doesn't have to do that much. We can do a lot of things on the front end. So some of the things you want to do on it is just to be the layer in front of the database and make sure there's valid queries coming in. Instead of RESTful JSON API, there's nowadays different alternatives to that. One of the problems with the RESTful JSON API is that it's resource-based. You might have your data in one API endpoint, you have the metadata in a different API endpoint, and if you find, for example, two different graphs with 3 different countries, you might be making up 15 calls to the RESTful API. To combat that, there's things called GraphQL or FileCore. I think GraphQL is made by the Facebook guys, and FileCore is made by Netflix. They are both based on JavaScript, but I will, in the end, give you a link that actually they have a Python port for the GraphQL already. So you don't have to know Node.js to use that. And I think on the next slide, I will explain a bit more what it does, but it can reduce the amount of requests to 1, exactly 1. You just tell what you need, and it compiles everything and returns in one API call. And keep the API design tied to the user interface and user experience you are creating. You don't need any additional features on it, and it just brings complexity where it's not needed if you try to over-engineer the API. And again, keep it simple. You will see later on why it's important to keep this part simple. so that you can add features later on. So file core, here's one example of the file core, what it actually means to. So what it means that is you basically give it a JSON graph, say what I want, and then it compiles it all and returns it. It uses this kind of JSON path syntax to say what it wants. On the top, it's a bit more verbose version of it, but I simplified it a little bit to basically, if I want the metadata for the Finland and I just want the name field, I just list it like this, and then I want the data for Finland for the population indicator from years 2001 to 2002. The syntax itself is usually a bit more complex, but that's basically what it did. And you can just add stuff. You can make the Finland as a list, and you just say, I want Finland and Germany and China. And you send that as a request to the backend. And the backend can compile it all together and just return you a JSON graph that is neatly combined into one structure. So that is super useful, and you don't have to be scared of showing 10 different graphs on your website, because you can just ask them in the same request, so you don't have to worry about it taking too many requests. Some things about the user interface. This is probably a bit more challenging part for the Pythonistas that are here. Nowadays, it's really powerful if you know JavaScript. And if you're not really comfortable, you don't know where to start, just pick one of the frameworks or libraries. We use a lot of React. It's actually more like an ecosystem and a library than framework. But if you want more frameworky JavaScript things for the front end, I would recommend trying out AngularJS or Ember or Aurelia. Any one of those are nowadays very fully fleshed and production-ready systems. For custom visualizations, we use D3 usually. I think for the data science types, that's probably their own quirky way to represent some of the things, but it allows you to do almost anything. It gets a little bit tricky when you want to do scalable things and you want to add interactions and you want to add layers and making sure that everything is working smoothly on all cases. But it's doable. But if you have a bit simpler use case, you should consider maybe chart.js or chartist.js or C3, that is simplified version of the D3. Those are actually pretty nice, and if you're just prototyping, I would just use those ones. You cannot control all of the aspects of the visualization, but they work really well. If you do anything related to maps, I would recommend Mapbox. It's really good for serving the maps. It has really nice base maps that you can just lay under the features that you want to present. And they have a mapbox.js that is built on top of Leaflet. That is very standard and full-featured library. And best part about Mapbox is that they have really good user developer documentation. So just go to their website and see their examples, and you will get started really fast. If you're not good with CSS, use Bootstrap or some other framework for that, and make interfaces intuitive to use. Especially when you're combining different data sets, it's kind of hard to keep consistent on the user experience, but for users, it's actually very important to keep the consistent user experience independent on what is the state, what is the indicator they are looking at, or what are the countries they are looking at. And make everything clickable. Nowadays, JavaScript is really powerful. It's really easy to create interactions, so make everything clickable, and they will play around with your visualizations as much longer than compared to them being static. And once you have the basics working, you can start adding cool stuff like recommendations, because you can process the data on the backend, and you can also do pre-processing on the ranges of values, so you can adjust the scales a bit better. So you can add a lot of, basically adding more context after you have the first prototype working. And remember to concentrate on user experience. Again, they don't care about your backend things or the raw data. They just care about what they see and what they can click on. Here's an example of our search box for the new upcoming Data World Bank org. We actually use the fuzzy search on the backend, so we check what are the indicators that match the exact word, and then later on we give them options that maybe they made a typo or maybe they want to click something else. So just giving them a lot of choices and highlighting the ones that they probably want to click. And actually on the same list, if some country happens to match also pollution, we throw all the data in the same search box and do an interactive, quick search experience for them. And one important thing is that you cannot expect what the user wants. So some people just want to browse stuff. So we have the browse by country, browse by indicator, and browse by dataset. They can just click it and see everything on the same page. Quick visualization list. How are we on the time? Okay, I think it's good. Quick checklist on the visualization. What are the items that are clickable? Before you start implementing it, decide what are the clickable things. It's very cool for the user point of view, if you can click around things and it moves around, or you can select other things on the interface by just clicking. And pay attention to the number formatting. This means if you have datasets that have millions and billions and thousands, try to have some consistent way of representing that. Sometimes it means that you have to actually process all the data things on the backend and then say what should be the scale for this indicator. So for the visualization, as I told, it can be a bit tricky to work on different scales, especially when you go down to the mobile scale. So if you are doing with D3, I recommend you from the beginning start thinking, how do I make it work on the small screens as well as big ones, because it gets very complicated if you don't take it into account. Decide what to do with missing data. It's not as simple as you would think, and sometimes based on the data that you are representing, you might have to have different ways to represent the missing data. Sometimes you want to maybe interpolate between the data spots. Maybe you want to have a dashed line, or maybe you just want to have some kind of full stop between those things. And it depends a lot on what kind of data you have. And some things that are kind of easy to miss is, should I show the 0 on the y-axis? Because it's very easy to confuse the user if you just show the values from 1000 to 1010, and then they think it raises from the 0 to the 1000 because it kind of looks like that on the visualization. So those are all kind of small, minor user experience things, but they can affect a lot on how the users experience the actual data. And leverage colors, but don't go overboard. People like colors on the visualizations, and they are actually really powerful on separating things, different kinds of information on the screen, but it can also get really ugly really quickly. So be conservative, but don't be afraid to try out different things. So I just want to show this again to you guys. If you have some data that you want to just start thinking, just build it out. It's really easy to get started building this out, and the data processor can just be your typical Python script. The database, we actually use Redis for some of the things, the simplest cases, because usually you can fit the whole dataset into the memory, and you just do the key value database structure, and you pre-process as much as you can. So you can keep the database, and once you have the database really simple, you can also keep the data interface really simple. You just basically map everything you have in database through the data interface or the API. So keeping those simple and closely mapped with the database structure helps a lot to add things on the future. And on the presentation, it can be a bit challenging at first to get familiar with the JavaScript frameworks, but don't be afraid. Nowadays, they have really good documentation, and you can do really powerful things on the front end. So don't be afraid to try, and I'm pretty sure you can get a prototype working like this very fast. And good point of it, if you do it like this, you can keep extending it. You can keep adding features. Let's say you want to add a search feature. You can just modify add a new data processor script and add a new database table and add a new endpoint to the data interface, but you don't have to touch any of the previous stuff. So it will have a scalable way to add features as well as add performance. Some of the resources you should check. We write a bit more about how we built the World Bank open data site on our blog. The backend is actually Node.js, so don't be scared. But you could as well do it with Python. As I told you, API is not the difficult part. They have a project called Graphene Python. It started last autumn, so I'm not exactly sure how production ready it is, but it seems really cool. It allows you to use the GraphQL on the Python. Mapbox tutorials are really good at showing you how to visualize geospatial data. They have really good examples. You can just copy the snippets and get started really quickly. MapShaper, that's the website I showed you that can simplify the shapes and really visualize it in real time, how it affects your shapes. And they have a GitHub project that you can learn more about what algorithms they use. PySHP is the Python library. You can read the shapefiles. It's not really perfect, but it works. D3 Calorie, it really gives you good view on what is possible to do with JavaScript and D3. So if you're not sure what direction you want to take, just take a look at the gallery. It has really cool examples. And World Bank Open Data beta site is actually public. We are planning to release it probably at some point, but you can access it with the beta.data.worldbank.org web URL. And thank you. That's it.
Okay, awesome. Thank you, Juha. And I think we have time for a couple of questions. Yeah, here's the first already.
Hi, thank you for the talk. I really liked all your tips about keeping the UX simple. I think it's really easy to forget when you're building it and you're so close to the data that it's not as obvious to other people. I had a question around whether you do much user testing, and if so, how you kind of structure it to get the most out of it.
I'm actually usually part of the engineering part, so it's not exactly my experience, specialty, but of course I see it happening. We tend to follow this kind of agile methodology, and we try to push our products as early as possible to the staging sites or our dev servers. And usually it's actually our clients that do the first user testing, and then maybe they organize the user testing. So we do some user testing on our own, but also it's partially hidden from the engineering team sometimes because we have the product layer in the middle. But as I thought, the philosophy is to push something out as early as possible and then let real users use it. I think that's the way to do it usually.
Another question.
Hi, one question. Because we are dealing a lot with reports and writing reports. Do you have any experience like making something slightly interactive, but that can be saved in a PDF and can be then transported around?
Well, we usually actually, I didn't mention it, but it's quite common that our data pre-processing pipeline actually produces different formats from that level already. So we write the data to the database, but we also save CSV files of the datasets and the Excel files and some other that we offer as downloadables from the website. So we have different formats. We use the database to actually do the interactive parts, and then we point to the static downloadables that are not quite as flexible, but they can get the complete dataset based on the screen they are seeing. So maybe some of the filtering is only on the front end, but they can download always the full dataset based on the static files on the server.
Okay, then I would suggest that we thank you again.
Thank you.